So I'll describe the problem statement. So the problem statement is that there is a two-dimensional grid,
Okay.
okay, which has 1 or 0 as a value in a block in the grid cell.
Okay.
Now we need to find out how many perfect squares are there.
Perfect square as in.
Yeah. So for example, right? Let's say this is my grid.
Okay.
So if I look at the first value 1, that gives me a perfect square.
Oh,
Right?
okay.
Now if I look at 1 and the adjacent value 1, that's a rectangle. It's not a perfect square. So I won't still qualify it as a perfect square for me.
Okay, so like square as in the shape square.
Yeah, shape square.
Oh, okay.
Okay. So there is a possibility that, I have 0 in between somewhere.
Yeah.
So I need to identify that how many perfect squares do we have in this rectangular grid.
Oh, right,
Okay.
right. Okay. Yeah, yeah.
Yeah. So you can assume the input format in the way you want, depending upon the language you will choose, right, to code.
So I'd like to code in like C++. I'd like to use C++.
Sure. Then you can consider it as a vector of int.
Okay, yeah, sure. So like since this is 2D and consists of counting, I would say like I would go with DP anyways.
Yeah, that sounds fine.
So like for any let's say like DP of I j is my answer, like equal to like a number of squares in a like subgrid which consists of like 0 to I
Okay.
rows and 0 to j columns. Like I'm assuming that the grid is 0 indexed.
Yeah, that's fine.
So like let's say this has the answer. I mean like dp of ij is my answer to this. Then I would somehow want to link it to like dp of I minus 1 j, I and j minus 1, and dp of I minus 1 and j minus 1. Okay. Um, so one thing we could see that is if either dp of I minus 1 and j or dp of I and j minus 1 is a 0, or dp of I minus 1 and j minus 1, either one of the three is 0, then we cannot form a square, like we cannot extend the square or something like that. Hmm. Okay, so like one more idea is um, to form dpij, like I'll need to check the row I and column j, and if like all of them are ones, then I could extend it to dp of ij. Like for example, 1 1 1 1, and then I have 1 0 0 1. So if I have the answer to like dp of 1 and 1, and like all others for except dp of 2 and 2, if I'm finding the value of dp of 2 and 2, then I'll go checking this one, the second column, and then the second row as well to see like if I can extend them.
So you will actually check the entire row or column there.
Yeah.
Okay. So just give it a pause there and try to think in what cases the if you want to put a hard constraint that all the values in the column or the row are actually going to be equal to 1, in what cases specifically that will not hold true. Just try to rearrange the zero, that zero which you see on the second row, right,
Okay.
to the first row.
Oh,
And
okay. So like this.
yeah, and or maybe let me change it. Just a second. So previously you had it something like this, right? So what I'm saying is, let's say you have this format, right?
Um, like I couldn't see anything. Are you changing
Oh,
something?
wait, I think, man, it will come there. Just give it a second.
Oh, okay.
Is is it the server problem, or but your internet seems to be fine? I can hear you properly. Can you do a refresh once?
Oh, yeah, sure. Okay, yeah, now it's okay. So like this is the final one, right? Like which you have done. Hello, am I audible?
Yeah, yeah,
Oh, yeah. So like, is this the one which you have?
yeah. This is the one.
Okay.
So if you're planning to check the entire thing, you may say that the value over here is not possible, right, at this position, which is 2 comma 2. But if you
Yeah,
look
yeah.
over there, you can see there's a grid, there's a square of size 2.
Oh, yeah, yeah, yeah. So, yeah, that would be a problem. Yeah. So, actually, like, I have to check at each position. What I'll try to do is I'll check it. Like, for example, I start here and like this is one of the perfect squares, right?
Yeah.
This 2 comma 2. So I'll just go one block this side and one block this side. I mean, like one step top and one step to the left.
Okay.
And then I'll check if all of them are ones.
Okay.
If both of them are ones, then I'll just yeah. So if both of them are ones, then I could do like dp of ij plus equals to since I'm adding it to okay, so yeah, I'll just do dp of ij plus plus. But that would cause a problem definitely. Like what if this was 0 and this was 1? So like and let's say this was 1. So I would check this one and I would check this one,
Yeah.
but still I can't form a perfect square of all these, right? So that would be a problem.
Yeah.
What else can I do? So like first I'll see like what are all the squares I could form like potentially just by including this. So basically I could form this one, and I could form the 2 and 2, that 2 2 with like just 4 square, and then the 9 square and so on. Okay, so mm, okay, so like for each of them, if I'm at this position 2 2, I'll just like look at these three of them, if they're like one or not. If all of them are one, I could increment my dp of ij. Okay, and then for the next one, I'll just see this, and like this, all of them. And if those are all one as well, then I'll increment it again. And until like if any one of them is actually zero. So in that case, I couldn't go like, I couldn't go further because there won't be a square.
Okay. Can you write sudo code for that?
Oh yeah, yeah. So basically like for ij, this would be like for int I probably equal to 1, I guess, because 0 would be the base case, and n is the number of rows, and let's assume that n is the number of rows and m is the number of columns. Okay, so um, for ij, what I'll have to do is, okay, so I just have to have another loop which is k equal to, let's say k 1. How far can it go? Hmm, um, okay, yeah. Okay, equals 1, k less than minimum of, let's say like nm. Okay, so this is k plus plus. So here what I'll do is dp of I minus k. Okay, so okay, so the first one I'll have to check this one and this one and this one. And if k equals 2, I'll have to check these two and these two, right? Okay. Um, I'll probably have to have another loop, but that is too complicated. I think there should be a simpler solution. I don't think I should travel all these
Yeah.
explicitly.
Yeah.
Okay. So like what could I see from this one? Um, so dp of I minus 1 and j gives me all the squares possible from here to the top. And this one gives me all the squares possible from here to top. Okay. Okay. Yeah. So one thing I could do is if dp of ij, like if dp of, let's say like this call is grid of I minus 1 j, grid of I j minus 1, and like if all of them are actually 1. Okay, so what I could do is I have to just increase the value like dp. Um, I should increase the value by some amount relating only to dp of I minus 1 j, I j minus 1, and I minus 1 j minus 1. Okay.
Okay. Can you explain this approach once again?
So like what I was thinking is probably I don't need to travel all these, but dp of ij, like if all of them are 1, I think the answer is only related to dp of I minus 1 j. I can construct the answer using I minus 1 j, I j minus 1, and I minus 1 j minus 1.
Yeah. Okay.
So like how would it look like? Um, so if all of them, so definitely one of them would be added, which is this one. And then if all three are 1, um, okay, yeah, yeah. So for all of the for I minus 1 and j, okay, that won't be possible. Mm, um, okay, so like if all three are 1, what I could do is, uh, um, so it should be like dp of I minus 1, j minus 1. Yeah, so it should be this. Because for every one of the dp of I minus 1, j minus 1, uh, I could like get an extra one. Like for each of them, I could build a perfect square for this one.
For
And
DP
then
of?
yeah, so like this
Okay.
plus one.
If all of them are one, that's what you're
Yeah,
saying?
if all of them are 1, all are 1.
Okay.
If that's not the case, then like probably I could, if one of them is 0, then definitely I couldn't get a square from this. So that'll just be 0, like 1 actually. dp of now for this is for the case when dp of ij, like grid of ij is 1, and then like if grid of ij equals 0, then outside dp of ij is 0. Is this equation correct?
Yeah.
Okay, is it so? Then I think that should be the solution. Like for the base cases would be like I equal to like the first row and the first column. So like everything else would be 0 in the columns and rows, like except 0 comma 0. This if it is 1 then it's 1. If it is 0 then it's 0. And rest all are 0 because
Okay.
rest all are 1, like similar. Like if it's one, then it's one. If it's zero, then it's zero. I guess the solution correct.
Okay, just give me a second. I'm still evaluating.
Okay.
Can you complete the pseudocode in the meantime?
Yeah, yeah, sure. So like for the base case would be um, this is zero, or this is for the first row. Yeah, so this is for the first column. These are the base cases. And the actual case would be okay, so it should be if grid of I j 1 um, then I would say dp of I j equals to 1 if grid of I minus 1 j and grid of I j minus 1 I minus 1 and j minus 1, then I could say dp of I j plus equals dp of I minus 1 j minus 1. Right, so else I would say dp of ij equals to 0. Yeah, so like this should be the, does this look correct?
Yeah, just give me a second.
Okay, sure.
Okay, let's take an example, and let's try to prepare a DP array for that.
Yeah, sure.
So I'm specify the, if you scroll down, you should be able to see.
Yeah.
So let's take this as an example. Let's try to prepare the corresponding DP array for it, and then the final value.
Yeah, sure, sure. This is the example. So like dp array would be so initially it should be 1 0 1 1 and 1 1 0. So like this is basically, yeah. So there should be 1 because like only one of them is 0, and this should be 1 again this should be 2 actually, yeah, 2. And then this should be 2. This should be 2. Um, this should be 2 again. And this is 1. This is 3. This is 3. Like this is the DP array.
Okay.
Um, okay, yeah, so definitely this is not right. Oh, yeah, I didn't consider this one. So, like, basically, we are considering every square, right? So,
Yeah.
like, 1, 1, this is, so everything's a square, okay. Um, so this definitely doesn't work.
Okay, just to give you a hint, you
Okay,
are
so,
thinking in the right direction actually. So
okay, yeah, yeah.
instead of thinking the final DP array is your answer at IJ location, try to use this as an auxiliary array where you are keeping some information which can help you finally compute something.
Oh, yeah, yeah, okay. Okay, yeah, yeah. So, like, basically, this DP array would give me every square which is ending at I comma j, not the
Yeah.
total number of squares. So like if I take the sum of all the numbers, or so like the sum of entire DP array, then that should give me the answer. Is that correct?
Can you repeat the first statement you mentioned that this array IJ will is giving you what?
Yeah, so this DP of ij will give the number of perfect squares which are ending at ij and the index ij.
Okay, if that is the case, then at line number 58, the first value 3 which occurs,
Yeah,
right?
first value 3, yeah, yeah.
That is not giving me the perfect square representation, right? For a square, or is it? I've got how many? I've got one over there.
Oh, yeah, yeah, that's not correct, yeah. I have only two of them.
Yeah.
Um, what else am I having from this? So what I'm doing is every time if all of them are 1, then I say that dp of ij plus equals I minus 1 j minus dp of I minus 1 j minus 1. Um, okay, so like what is the total number of squares? That should be, there are many of them actually. So how is this dp array useful to me? Um,
Okay, think from this perspective. Let's say you have a square and you are moving. Right at the edge of the square, what you see right now is basically 1 1 1 1 1. Okay,
okay,
let me try to show it by an example. Just a second. So below DP, I'm going to add, right? So
okay,
if you have a square, for example, something like this, why it is highlighting? You're able to see? No, man. Can you do a refresh once?
Yeah, sure. Yeah.
Okay. So if you look at this array, right, while going down the diagonal, right,
Okay.
the type of the square you're dealing with is changing. So when I look at the very first value, I know, okay, there is only just one square possible with length 1.
Yeah.
And then when I look at 0 comma 1 value, same thing at that place also over here. I'm not able to show you live. I don't know, it's taking time to refresh on your side.
Okay. Yeah. 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 Okay. So like every time we are seeing like the length is changing.
Yes.
Okay. Like for that, we probably have to traverse, right? Because we don't know like so like dp of I minus 1 j and I j minus 1 could be 1. That will give me a that will prove like I can say that it's 1. A square of length 2 is possible, but it is possible that dp of I j minus 2, I minus 2 and j might be 0.
Yeah, but you don't
Okay,
need to
yeah.
worry about
So
that because
yeah,
of
yeah,
DP.
because it is dealt
Yeah.
in dp of I minus 1 j. Okay, okay. Um, okay, so like I have all the possible answers for I minus 1 j, I j minus 1. Okay.
Okay, let's go through the approach once again, right? So when I'm looking at a diagonal of a square, right, I
Okay.
know the value is going to increase because when I look at the first value, it's square of length 1. When I look at the second value on the diagonal, I know now I have basically I have a square of length 2. When I go to the third one, I see I have a square of length 3,
Okay, yeah.
right? So if I try to work with that kind of auxiliary array, let me just add it here. Can you refresh it once?
Yeah.
Oh, you'll have to do it again. Still doesn't have the latest data.
Oh, yeah. Yeah.
So if you see this array, at any point of time, or at any point in this particular grid, right, at I comma j, I can get to know that what is the maximum square possible, what is the maximum length of the square possible at that particular I comma j,
Oh, yeah, yeah.
right? So if you look at the value of 2 on the second row at the last,
Yeah.
there also I only have 1 1 1 1. The maximum length available there is 2 for the square.
Oh,
But the
yeah, yeah.
moment I went down to a cell below, now I can say that I can try to support the length of 3 for the square, right?
Oh, yeah. Yeah.
So if I try to look in my neighborhood, what are possible lengths are available, right? And what is the minimum of them,
Oh, okay. Yeah.
right?
Okay.
I can contribute to that one to increase the size.
Oh, yeah, yeah, yeah.
Okay.
Um, okay, yeah, yeah.
So let's go back to the DP array which you had created from line number 54. Now don't think of it as a DP array. Think of it as a, or if you want to think it from a DP array, you can think of it that instead of solving for how many subsquares you have, you're solving for what is the maximum length at this point of time you are able to create a square for, square of.
Oh, okay.
Then how would you now restructure it? Or what would be the new DP array?
Okay, so maximum length, yeah. So if it's zero, then that's definitely zero, and for the first and first column, it'll be similar. And now this for this, um, for the maximum length, I have like 1, 0, and 1. Um, so like it'll be zero because the minimum is zero, right? Uh, okay.
This this itself has some significance. This particular cell also is qualified to be a square.
Oh, yeah, yeah, yeah.
So what should be the value
Okay,
here?
so I have one, like one is already there because itself it can form a square of length 1. Um, so can it form a square of length 2? It cannot because like the minimum of all the neighbor values is 0, right? So it cannot go from 0 to 2. Like it could go from 1 to 2, but it cannot go from 0 to 2. So that's the reason
Yeah,
it should be 1.
yeah. So that's why that is the reason we look out for the minimum because we can only contribute to that.
Oh, okay, yeah. Okay, so that should be like the minimum of them plus 1.
Yeah.
So like this should be 1, and okay. So that would be the maximum length square which I could form from that position.
Yeah.
Okay. Uh, so from this I should get the number of squares, total number of squares. Okay, so yeah, yeah. So like it should be the sum, right? Because uh, the maximum length which can form, like if I'm able to form a length of 3 square, then I'm sure that I could form length 1, 2, and 3.
Yes.
So like the answer would be the sum of all uh, the array elements.
Exactly.
Oh, okay.
But there are still some issues with the DP array. Let's go ahead and make it complete because I
This
want to go
array.
through the entire, yeah, go through the entire process once. Then we will move to the pseudocode.
Okay, sure, sure. So like this is 1, 0, 1, 1. So the base cases are right because they're just the elements of the grid.
Yeah.
And here I'd say the minimum is 0 and that plus 1 is 1. That's correct. And here the minimum is 0 again and plus 1 is 1. Here the minimum is 1 plus 1 is 2. Here the minimum is 1 again plus 1 is 2. Here the minimum is 1 plus 1 is 2 again. Again 2 here. Okay. Here I have the minimum as 0 and plus 1 as 1. Here I have the minimum as 1 and plus 1 is 2, and this is 3.
Yeah. Good. Okay. Let's proceed with the code.
Okay. So like This should be the case. Okay. So this the base case would be same. Instead, I don't need this. I'll just say grid of I j. Okay, so yeah. Now here what we'll do is dp of I j equals minimum of dp I minus 1 j minus 1 and minimum of I minus 1 j I j minus 1 plus 1. Yeah, so that should be my dp array. Yeah, okay. I'll have total squares variable which is running, and okay, I should declare it here for the base cases as well. So while I'm constructing it, I'm just increasing the value of the total squares.
Yeah. Have a look at the variable also you're using there, no? Line number 37.
37. Oh yeah, yeah, yeah. I made a mistake. Yeah. Okay. Again, total squares plus equals dp of I a. Right. So that should be like I should return total squares, and um if either n or m is 0, then I could probably return minus 1. I'll add that too.
Yeah, that's okay because your base case will take care of total squares of 0, right?
Yeah, yeah, yeah.
Okay. Now just pause it over here and think that whatever the condition you had before, is it valid over here or not? That you are supposed to do this computation of finding out the minimum across my neighbors and then giving my contribution to that minimum if I have the value as 1.
So sorry, could you repeat?
Okay, let me show it by an example. So above the DP array, right, there is an example for which you prepare the DP array.
Yeah.
Let me introduce another 0 in between. Can you do a refresh?
Sure. Is this the one?
Yeah. Try to compute the DP array for this.
Okay. So this is pretty safe. 1. This is 1 again. Okay, so this is what is changed, right? Okay. This would be 1. This would be 1, and this would be 1. Rest all should stay the same. Yeah, is this right?
Yeah, but the code which you had written, apparently because of code share, it's gone, but that's okay. You didn't have a place, you didn't have any condition specifying that you're supposed to look for minimum when the value is 1.
Okay, yeah, yeah. Oh, yeah, the code is
That was
gone.
another missing piece.
Oh, yeah, yeah. I should have checked if it's 1 or not. If it's 0, then I should put 0 over there.
Exactly. Okay, so yeah, that's all from my side. Uh, Unfortunately, we can't go for the second question. It's very late.
Okay.
right? But you are able to understand, right, that you always in a DP question, no, you don't need to actually go for the exact problem statement which is given in the question. Sometimes a sub problem is what the DP problem is supposed to be, and a little computation on top of that should give you the answer for the question which has been asked. So over
Okay.
here, we've converted a problem statement into two. First, find out that what is the maximum length of the square I can have till ij. Right?
Yeah.
Using that information, we were able to compute how many subsquares are available in the rectangular grid.
Yeah, yeah.
Yeah. I think that's all from my side. Anything specific you have you would like to ask?
So like what areas should I improve? Like apart from DP, like DP, I know like my DP is not pretty good, so like I should practice.
Yeah, this is primarily from practice, right? Once you start doing more and set of questions, you will be able to relate also to different kind of problems which can arise while dealing with DB. So that's definitely there. And I think last time we discussed that you should definitely focus more on linked lists and graphs, right? So that's
Yeah.
another area where even in online rounds and in face-to-face interviews, companies tend to ask standard set of questions.
Okay. Like apart from the coding part, like is there anything else should I improve? Like my talking and stuff.
No, this time this time it was better than the last time whatever interview experience we had, right? So you were able to communicate whatever you were thinking. That's a good thing. One extra point which I can say for you would be that add annotations to your code, basically add comments where you are making an assumption or so for example, this part, right? Line number 38, that if grid ij equal to 1, just add a comment that why do you think that this if condition should exist there,
Oh, okay.
right? So I'm not saying that you should try to think about it, okay, where all I can add comments. No, while you are describing your solution, automatically you're going to say some words, right, to the person on the other side. Document the same thing in the code, because usually what people do, what other companies will try to do, they'll have a code share link which they will save that as a draft. So
Okay.
while you are explaining, definitely the interview knows what you are doing. But once this is saved and is shared with other team members, then all that contextual information is gone. But if you add them as comments over here, they will basically anyone who is looking at your code will be able to relate to it.
So like I was thinking like if I comment like everything, then that'll probably take a lot of time, right? So
Yeah,
would that
not
slow down?
everything. Not everything. See, you don't need to say that I will iterate over all the values in the array. That's implicit. Everyone looking at the for loop can check it. But why do you have that specific if condition? That is something you should put.
Oh, yeah, yeah.
Okay, why are you taking the minimum? That is something you should put in array or put in your code. Sorry.
Yeah.
Okay. There are going to be cases. For example, in graph traversals, you will take a decision of whether I'm supposed to go to this particular node or not. Most of the cases is going to be very basic decision, so you don't need to put it as long as you use the right variable names. But in case there is some complex situation over there, you're using stack, you need to identify when I'm supposed to pop from the stack or push to the stack. Just document that one particular thought of yours as a comment.
Oh, yeah, sure.
Okay.
And like one more thing is like for internship interviews, like what is the level of problems generally?
I won't say people will ask hard questions, but definitely medium set of questions from lead code are compulsory.
Oh, okay.
Yeah.
Great, cool. And like also like how many questions are covered like generally? Like if it's a good interview, like how many are covered?
See, for a general interview, I think we discussed last time also, now that for general interviews, you'll have roughly around uh, one or two, actually one only, one online interview, and then four offline interview. Now everything is online, but I mean to say The first one is aptitude plus two random set of questions, and after that you have like proper interviews where you they will per interview they would like to ask you two set of questions. One of them or two of them can be coding questions, but it's going to be a mix. They'll ask about design. They'll try to focus on your theoretical knowledge also about the operating system, database, network, like Amazon. These type of companies, right? This they will try to inspect on that front also. So you can expect at least 4 rounds. That is from Amazon, and I think I can say Google also. But other companies they will try to limit it to 2 rounds for internship,
Okay.
right?
Yeah, yeah.
But for full time, but you're not applying for full time, so that's a different thing. But in general, I'm saying like for full time, there's going to be usually 4 to 5 rounds.
Okay.
Yeah, but be ready at least minimum, like at least two set of rounds are going to be there. Be ready for that.
Yeah, yeah. So like any like general improvement which I could do like for the next interview.
One thing I would suggest is that try to keep a notebook where you can specify what all mistakes you're making. Right, learning is definitely an important thing to understand how can we solve questions, but also understanding how can you spot your mistakes well next time will help you.
Oh yeah, sure, sure.
Okay,
Yeah.
cool, sir.